The nature of light, a historical perspective. At the turn of the 19th century, scientific opinion was divided over the question of the nature of light. Isaac Newton had argued that a beam of light is made of countless tiny, fast-moving corpuscles. If light consists of these bullet-like corpuscles, he said, this would explain why light travels in straight lines and casts shadows. But Newton's corpuscles did not explain why light refracts or splits into the colors of the rainbow, also an effect of refraction. Christian Huygens had argued that light comprises not particles, but waves. If light travels as waves, Huygens said, it is easy to explain these effects. However, Newton's stature was such that most scientists backed the particle theory. Thomas Young and the double-slit experiment. Then, in 1801, British physician and physicist Thomas Young hit on a design for a simple yet ingenious experiment that would, he believed, settle the question one way or the other. The idea began when Young was looking at the patterns of light made by a candle shining through a mist of fine water droplets. The pattern showed colored rings around a bright center, and Young wondered if the rings might be caused by interacting waves of light. Young made two slits in a piece of cardboard and shone a beam of light onto them on a paper screen placed behind the slits. The light created a pattern that convinced Young that it was waves. If light were streams of particles, as Newton said, there should simply have been a strip of light directly beyond each slit. Instead, Young saw alternating bright and dark bands, like a fuzzy barcode. He argued that as light waves spread out beyond the slits, they interact. If two waves ripple up or down at the same time, they make a wave twice as big and creating the bright bands. If one wave ripples up as the other ripples down, they cancel each other out in creating the dark bands. Young also showed that different colors of light create different interference patterns. This demonstrated that the color of light depends on its wavelength. Understanding light, particles, or waves. If light is made of particles that travel in straight lines, then this can be proved in a simple experiment. Shine a light through two adjacent slits onto a screen. Two pools of light should be seen on the screen, but instead, it creates interfering patterns of light and dark, just as water waves would if water flowed through two slits. Light must travel as waves. Einstein's revolutionary insight. For a century, Young's double-slit experiment convinced scientists that light is a wave, not a particle. Then in 1905, Albert Einstein showed that light also behaves as if it were a stream of particles. It can behave like a wave and a particle. Thanks for watching video, and don't forget to subscribe.